Okay, so in this short video we're going to be looking at how you can actually factorize a cubic using grouping. So it's going to be quite quick, but this is one approach to actually factorizing a cubic. And it works most of the time. So let's just have a little look at what we've got here. We've got a function f of x to the 3 plus x squared take 7x take 7. That's our f of x, and we want to be able to factorize that. So what we do is we take the first two terms and the second two terms, and we actually group them into two separate groups in between a plus sign. So what we'd get is essentially this. Really easy. All you can see is I've just taken those first two terms, plopped them into that bracket, taken those second two terms, plopped them into that bracket. There we go. So now the next step is to actually look for a common factor. So what we want to do here on this side is find a common factor between those two terms. And obviously we have x to the 3 plus x squared. In order to find a common factor, we can obviously look for the key thing that's shared, which in this case would be x squared, because of course this is just like having x times x times x to the 3, and x squared is just x times x. So x squared would be the common factor of this side. So what we do is we bring that common factor out the front, and then we rewrite the bracket. And we get x plus 1 in the bracket, so when we expand that out using the distributive law, we get x to the 3 plus x squared, which is exactly the same as up there. We just isolate a common factor, and this will become more apparent as to why it's necessary in just a moment. But we do the same on the other side too. So on the other side of the plus, we look for a common factor, and we can see, obviously, we've got negative 7x takes 7. It's pretty likely the only really common factor we can have is, of course, negative 7. So we've got negative 7 there as the common factor. And then what we've got to put in the rest of the bracket is simply the leftovers after we've taken that common factor out the front. So it's negative 7x, so of course it's going to be x. And surprise, surprise, we've got negative 7 here, and we need to get to negative 7 as well, so it's going to be plus 1, because a negative and a positive make a negative. So we've actually got, as you can see here, x plus 1 and x plus 1 there. And there's actually a reason for that. That's because it's a key part of the process in finding the roots. So what we do now is we actually take what we've got, and we take these terms, the common factors, and put them into one bracket. So we've got x squared take 7, because those are the common factors. And then what we do is we take the common factor between both sides of the plus, so it's x plus 1. And we've pretty much factorized, but we can go to an even nicer state. Now, we consider x squared take 7 as being dots, the difference of two squares. So we've got x squared take a squared equaling x take a and x plus a. You would have seen this when you're just factorizing quadratics and second-degree polynomials before. So we can actually rewrite out this expression to suit that format. So we've got x, one's plus and one's minus, and obviously what we need here is, this is a squared term, a squared, so we need to find a, and of course the square root of 7 is the square root of 7. So essentially what we're doing is because that's a squared term, we're putting square root 7 here and square root 7 here. Because if you wanted to, you could actually expand to check, but of course with this cubic factorization process, what we've got is essentially the roots now. And this means, of course, when you've actually looked at quadratics before, you'd understand, but we can get x equals square root 7, x equals negative square root 7, and x equals 1 as the roots of this cubic, purely based on the actual brackets. X, again, this expression we're assuming equals 0. And hopefully that was an insightful video as to how to find the roots. Of course, this is when we're assuming that f of x equals 0. If you have any questions, let me know, but there's the factorized form for the x values, the roots of the equation, and using a basic cubic factorization method. Thank you.